Welcome to the second part of VCAA Specialist Math 2022 exam papers. In this video, we will present exam paper 1, questions 5 to 7. Both questions 5 and 6 were answered well with the number of equivalent correct answers given by students. Successful students often annotated the diagram in order to resolve the forces, although some algebraic errors were made, leading to incorrect conclusions. In question 7, many students used a trigonometric identity to expand the compound angles of cosine function before differentiating. However, few students who used this approach were able to find the correct answer. Many students found themselves overwhelmed by the large number of terms produced using this method.
Hello, Math Champions! I'm Dr. Chen. If you want to improve your math skills and understanding so that you gain confidence, enjoy math more, and get better results, click subscribe and hit the notification button so that you don't miss anything.
Welcome to this VCAA Specialist Math exam paper series. In this video, we will present questions from 5 to 8 of Exam 1 2022 paper. The first exam paper consists of 10 short answer questions, while the second exam paper consists of 20 multiple choice questions plus 6 extended response questions. Let's start from question 5, which states that a body of mass 10 kilograms. Initially, it is at rest and then it slides down along a smooth inclined plane as shown in the diagram. The plane is inclined at an angle theta to the horizontal, where tangent theta equals 1/3. There are two parts in question 5. Part A is to find the speed of the body after the body has been in motion for 2 seconds. Part B is to find the constant braking force, which is applied to the body parallel to the plane so that the body has constant velocity after it has been in motion for 2 seconds. Now, let's start with part A of this question. According to the diagram, the component of the weight parallel to the plane is mg times sine theta. Based on Newton's second law, mg times sine theta equals ma. So the acceleration of the body, a equals g sine theta, which is a constant. Then we apply the motion formula. V of t equals u plus at. Here u is the initial speed of the body, and in this case, it equals 0. Then the next step is to find the value of sine theta. Since tangent theta is equal to 1/3, and we know cosine theta equals 1 over the square root of the result of 1 plus the square of tangent theta, which equals 3 over square root of 10. Hence, the acceleration a equals g times tangent theta times sine theta, which equals square root of 10 times g over 10 meters per second squared. Since the acceleration a equals square root 10 times g over 10 meters per second squared, and the v of t equals at, which equals square root 10 times g t over 10. So v of 2 equals square root 10 times g over 5 meters per second. Since part B is to find the constant braking force, which enables the body sliding down at a constant velocity, mg times sine theta minus r equals 0, as shown in the diagram. Hence, r equals mg sine theta, which equals square root of 10 g newtons. Question 6 has two parts. Part A is to find the cosine of the acute angle between vectors A and B, where vector A equals 2i minus 3j plus 6k vector b equals I plus 2j plus 2k. In part B, as shown in the diagram, it states that OPQ is a semicircle of radius a which satisfying the equation y equals square root of the result a squared minus x minus a, or in parentheses squared. Here, the point P, X, Y is on the semicircle OPQ as shown in the diagram. Part B has two sections. Section 1 is to express the vectors OP and QP in terms of A, X, Y, I, and J, where I is a unit vector in the direction of the positive x-axis and J is a unit vector in the direction of the positive y-axis. Section 2 is to use the vector dot product to determine whether vectors OP and QP are perpendicular to each other. Now let's start with part A. According to the definition of vector dot product, cosine theta equals vector A dot product vector B over the product of their modulus, which equals 8 over 12 after the corresponding values being substituted and calculated. Since cosine theta equals 8 over 12, which gives theta approximately equals 67.61 degrees. The first section of part B is to express the vectors OP and QP in terms of A, X, Y, I, and J. According to the diagram, we have vector OP equals xi plus yj and qp equals x minus 2a, or in parentheses I plus yj. Since section 2 of part B is to determine whether vector OP is perpendicular to vector QP, what we need to do is to check if their dot product equals 0. So vector OP dot product vector QP can be written to xi plus yj, or over the result of x minus 2a, or in parentheses I plus yj, which can be simplified to x minus a, or in parentheses squared, plus y squared minus a squared. According to the given semicircle equation, y equals square root of a squared minus x minus a, or in parentheses squared. After both sides of the equation being squared, it becomes x minus a, or in parentheses squared, plus y squared minus a squared equals 0. Hence, vector OP dot product vector QP equals x minus a, or in parentheses squared, plus y squared minus a squared, which equals 0. So here we have proved vector OP is perpendicular to vector QP. In question 7, a curve has the equation x times cosine of the sum of x plus y equals pi over 48. The question is to find the gradient of the curve at the point pi over 24, 7 pi over 24, and get answer in the form of a times square root of b minus pi all over pi, where both a and b are integers. To find the gradients in the given implicit function, the technique of implicit differentiation is applied here. So the differentiation of x times cosine of the sum of x plus y with respect to x equals the differentiation of pi over 48 with respect to x, which equals 0 because pi over 48 is a constant. So the left-hand side of the equation is expanded to dx over dx times cosine of the sum of x plus y plus x times the differentiation of cosine of the sum of x plus y with respect to x, which equals 0. The equation is being further arranged and the steps are shown on the screen. And finally, y prime equals cotangent of the sum of x plus y over x, then minus 1. Hence the gradient of the curve at the point pi over 24, 7 pi over 24 equals cotangent of pi over 3 over the ratio of pi to 24 minus 1, which equals 8 square root 3 minus pi all over pi.
If you enjoyed this video, please give it a thumbs up and subscribe to help me make more math content like this. I will see you in the next video.